Very good morning, students. All of you have just now from the 12th B standard, you have studied the first lesson, which is rotational dynamic. I have given you the notes and solved examples also for 12th A. You can prepare all that one and read at least and write down in one of the notes. This is sufficient for all the students. If you have prepared that, then you will get the idea about it. And if you have written that notes in your notebook, then you will get the concepts which are given there for that topic. In this lecture, I am going to start the next lesson, which is mechanical properties of fluid. In the next lecture, that is the mechanical properties of fluid, we have to discuss the properties related to fluid. What are the properties and what are the behavior of that particle or that fluids that we have to find. So that in this case, what are the things we have to remember here? In this case, we can start like this. Mechanical properties of fluid. Everyone can understand what is the mechanical properties of fluid in this lesson. This is the lesson number 2 in paper 1. So here we have to find out like the same thing related with mechanics. So mechanics is the first part of our syllabus that we have to find. What is the meaning of fluid? You have already studied the particles which are in the form of now we are going to see the part of this that is you have to study in the 12th standard. It is in the form of 4 to 7 marks. The weightage of that lesson is 4 to 7 marks. Means compulsory 4 marks are always there. In CET examination, 3 marks questions are there. So that the board syllabus we have to complete here first as our board syllabus. And according to the board syllabus, we are completing this lesson for 4 to 7 marks. And for CET, there are 3 marks questions based on this rules. So we have to study for CET examination, 3 marks are there. For board examination, 4 to 7 marks are there. This means that maybe 4 marks question is compulsory question is there, and then option is also there having 3 marks. So you have to remember like this. What is the meaning of fluids? You have already studied the 3 states of matter. What are the 3 states? We know that solid, liquid and gaseous state. Fourth is also present there. It is a plasma state. But we can consider in our daily life 3 states like this: solid, liquid and gaseous. In a vacuum, there is a plasma state. But we are not related with the plasma till 12th standard. So that we have to see solid, liquid and gases. In the case of solid, we have studied first lesson. In that case, we we have considered rigid body, any type of body, and then frictional force whenever two bodies are in contact with each other, then the frictional force is created. In this lesson, we are going to see the gases state. So in that case, what are that liquid and gases both are combined together can having a simple property. Both are in the motion. But we can't say that it is in motion. We can say that it is in the flow. And that's why this liquid and gases combinedly called it as fluids. They can flow. Fluids means what? A substance which can flow. Any type of substance which can flow. In our daily life, we have seen there water is a liquid which can easily flow. There are two types of liquids which we are considering here. What are the two types? That is, first type is a real fluid. It is called it as a real fluid. And secondly, that is ideal. And to study the properties of matter or to study the properties of fluids, we have to consider ideal fluids. What is the requirement of ideal and what is the requirement of that real, that we must know. In the case of real fluid, we can say this as air is nothing but a real type of gas. In this case, we can see that water is nothing but a real liquid. But to see the exact properties or performance of that, or we have to see the concept related to only the ideal. Ideal fluids are required to see the behavior. And mathematically, we are going to present that fluids in the case of mathematical equation in physics. And that's why we can see this as, instead of this real, we are considering ideal. Ideal means selected, that is, already the same factors are there, but they must have to see all these properties which are given there. What are the properties that we can see that? So that first you have to remember, whenever we are going to observe the properties of matters, then we have to consider ideal fluids. And for that ideal fluids, what are that properties that we can see? So first of all, you have seen what is the fluids. A substance which can flow is called it as a fluids. Now we can see the shear modulus of fluid. Second topic, second point you must know about this ideal fluid is like this. What is shear modulus for fluid? That is, the shear modulus for fluid is 0. What is the meaning of that? If you have applied the force on any type of liquid or gases, it is not changing its shape and size. It is remains as it is. If I have taken some type of some amount of water and then if I have pressed there, then you can observe there is no effect of force which we can observe in clay. If I have considered one clay and one material of clay and applied the force, then it will change its shape. If I have applied the force on elastic, then elastic will be changed over the position. Maybe outward and downward forces will change the position. But in the case of water, if I have applied the force, a simple factor may be changes for that water. So that shape of that is not going to be changed. But if I have considered that inside any shaped bottle or any shaped vehicle, any shaped vessel, then you will observe there the vessel, the shape of that vessel contains by the water. Or water poured into that one is with the shape of that container. So that the shear modulus of that fluid is 0. Don't take any type of tension. What is shear modulus? That is, it is not going to change the shape and size whenever the forces are applied on it. जेव्हा तुम्ही फोर्स अप्लाय करणार आहे तेव्हा ते त्याचा शेप बदलणार नाही. वॉटरवर फोर्स अप्लाय केला तर तो इकडने इकडे कुठेतरी व्हेरी होईल म्हणजे फ्लो होईल अँड दॅट्स वाय इट इज अ part of fluid. So that for any type of fluid, if I have considered ideal as well as real type of fluid, then shear modulus for that fluid is equal to 0. Means there is no change by application of force. Obviously, when the force is applied in only one direction, then the motion will be changed. But shape is not going to be changed for fluid. This is the property that you have to remember. There are two types. Basically, this lesson is divided into two parts. What are that parts? That is hydrostatic. Second part, that is hydrodynamics. What is the difference in between these two? If I have filled one of the glass and I have kept it on the table, then the glass is nothing but the glass is as it is at the rest position, and that's why we can see the glass is changing as it is, the force is actually there, and then after we have to see that water inside the glass. What happened? The glass is at the position, the frictional force is also acted on it, and everything is as it is, but it is at the rest position. No water is changing its position, and water is as it is. So glass is also as it is. So it is called it as hydrostatic, as it is at the rest position. There is no change and rest. It is the first part of this fluid mechanics, hydrostatic and rest position. Second part is there, hydrodynamics. Hydrodynamics means it has a property that is it is flowing through one of the direction. And so that whenever any type of fluid is going in one of the direction, then it is nothing but hydrodynamics. We have also seen that the flow of water in rainy season are also travel by any direction, and you whenever it is traveling, then it is going along with one direction. The flow is not constant. Its velocity may be changes. Time to time you will observe there, that is the flow is not constant. But instead of this, if I have considered tap water, then the flow of that is constant. So that each and every particle is moving with the same velocity. In the second case, whenever it is not moving with the different type of velocities, we can say this as turbulent flow. In the rainy season, we can see that on the road. On the road, the various velocity is there, and then the water is flowing on the top of that road with the different velocity. So this is the two type of flows. First is turbulent flow of liquid. Second is a steady flow of liquid. So steady flow of liquid we are using in this lesson. So these are the introduction which we are going to observe in the form of mechanical properties of fluid. Then what are the properties required for ideal fluids? What are the properties? That is, the first property, it should be incompressible. Incompressible, the water is also like that. The water I am giving the example, and that's why that is not the ideal one of the liquid which we are considering. But in the daily life, you will get a very idea clearly for that water which is incompressible. Means I can't consider water in my hand and then I am applying the compressible force on it and it is going to be compressed. Like a clay, if you have used a piece of that clay and if you have applied the force, it will take its shape accordingly. So that it is not possible in the case of fluids. It is irrotational, means possibility of motion is there. it has the property of possibility of motion in any direction. It is not along with the applied force, but maybe sometimes applied force, due to that applied force, the flow will change its position. Non-viscous. Non-viscous means a viscosity means what? If I have considered one of the particle and if I have kept it on it will be remains as it is. If you have taken the piece of mercury and if you have placed it on the surface, what happened? By using that mercury, you will get a spherical surface on that plane surface if you have taken one of the mercury like this. If you have placed the water on it, you will get a water is like this. The bubble of that water can be observed in this way. So that the viscosity of mercury is always greater than the water. In this case, we have to see non-viscous, means the fluid must be non-viscous. Steady flow, obviously, it must be flow from one point to other point, and that's why it has a steady flow of matter. So these are the properties which you have to remember. Any type of property may be asked for MCQ question. So that this is one of the very important lesson for MCQ type of questions. And that's why remember the properties very properly. It is incompressible, it is irrotational, it is non-viscous in medium, and the flow of that fluids must be steady flow. Means we are not considering that turbulent flow, we are considering that turbulent flow for fluids also, but for observation of the properties, we must have to consider that fluid in a steady flow. So that this steady flow is required where the velocity is constant. At any point, the velocity, suppose I have considered this type of tab or that type of substance is placed over there. The velocity at this point is remains v. Then it is flowing in this direction. At this point, I can see that velocity may be changes. But after some time, if I have seen what is the velocity at this point, it should be remains v as it is. So these are the properties you have to remember, and in this case the first factor always remains constant. At any point if I am going to observe what are the properties of that liquid, it must be constant. Secondly, we have to find out the pressure applied on any type of body. You have also seen that if we have considered a water surface, any water surface, and if you have placed some of the object on it. We have also studied there. We have also studied there the particles which are heavy. Then you will observe that heavy particle is inside the water. If a light particle I have placed it on the water surface, then you will observe there that it must be on the surface of water. So everywhere the pressure acted on that body is different. And what is the difference? It is depends on mass of that particle. So obviously mass of that particle when you are considering, it has some type of pressure. Any substance, any liquid, if you have considered any type of liquid, then you will observe there these properties can be considered for the behavior. But if I have considered one of the vessel and then the liquid is placed over there, like this. Inside that, if I have placed one of the cylinder and the water is placed here. So that any object, any type of object, whenever inside the water surface, then you will observe there one type of force. You know that which force you know that is the gravitational force, which is acted in downward direction. But at the same time, the water opposes this one force. Which type of force? It is a viscous upthrust force acted by that viscous medium. Means in short you can remember that this liquid medium also exerts one type of force on this body. Exactly it is opposite like this. And due to that, both the forces are there. Where both the forces are equal, attack or attracted or towards that one body, then the downward force and upward force, when both the forces are in equal magnitude, then the body will attempt a velocity. That velocity is called it as terminal velocity. That we have already studied. Terminal velocity means it is not unlimited, but when the two forces are acted on that body is equal and opposite, then the body can attempt one type of velocity is called as terminal velocity. This is not our part that we have to study. We are going to study what is the pressure acted on any type of body which is inside the fluid. So suppose I am considering this type of cylinder placed on placed inside a viscous medium if its area is A. This area is A. Means area of the cylinder is A. It is placed at its certain height H. Means I have considered it is at the height of that cylinder. The water surface is as it is, and inside that it is placed over there liquid. This is obviously the air medium and this is also the water medium because for our simplicity we have taken water. Oil also I am taking and then I can find out what is the pressure. But for general we have to use air and water is easily available everywhere to find the property. So that this can be as it. Having area A, height is H, the water medium is present here and inside that we have to find pressure. Pressure due to liquid column. This is one of the very important derivation you have to remember always. Air pressure is called it as atmospheric pressure. We are always using that is atmospheric pressure. What is its meaning? Atmospheric pressure. So that this atmospheric pressure, always you are using their atmospheric pressure at a different type of pressure. But what is the meaning of that? It is the pressure due to air. He is called it as atmospheric pressure. And now here we have to derive the equation for any type of body. So I have considered a cylinder which is placed inside that. And now pressure due to liquid column I have to calculate. I told you that the two forces are already there. First one is known to you. When the gravitational force is acted there, it has some weight. So that no one can see there the gravitational force is acted on that rigid body separately. It is always depends on mass of that body. So that this pressure I can write. In the 11th standard we have studied pressure is equal to force upon area. This is a simple thing that you are always using there, the equation for pressure. Force upon area. It is equal to, what is the force in this case? M into mg upon area as it is A. But if I am going to find out, I can also write M is equal to P into A. And by using this equation, I can write mass is equal to, or capital M I have used here, M is equal to volume of cylinder multiplied by density. And that can be written A into H as volume is area into height is AH into rho is equal to, but M is the mass of that body. We are going to find out what is the pressure acted on that cylinder. And that's why to find out this equation AH into rho by using the value mg. I am using this equation, and for that purpose I can write this as equation number. We have to write by using equation 1, M is equal to AH multiplied by rho and G is as it is divided by. So you can see that in this equation, what is that? Equation 1 is nothing but pressure equal. The area is a common factor, so that in numerator and in denominator I have cancelled it. What is left there? That is H rho. So that the atmospheric pressure is a pressure due to air. But whenever in air also, all that particles are also in the fluid. It is also included in fluid. But I am going to find out inside the liquid. And that's why in liquid that pressure P is equal to H rho G. Remember this formula, and we have to verify so many derivations as well as so many concepts related to this. But till now, you have to remember pressure due to liquid, because I have used here liquid. Pressure due to liquid of the cylinder or any type of cylinder at a density rho can be calculated like this. So this is what the derivation you have to derive, and we can write, you have to remember only this derivation, that is the pressure acted on any type of cylinder can be written like this H rho G, where H is height of that column, where any body is having different type of height, but H is the height. Rho is the density of the medium which is used there to find the pressure. G is the gravitational force which can be acted in the liquid. So that pressure at any point inside the liquid can be calculated like this. You have already studied there, that is the pressure can be measured. Pressure can be measured by which type of SI unit? P is equal to force upon area, that is Newton per meter square. Always we can measure the pressure by the SI unit, that is Newton meter square. And in the case of sometimes it is also measured by Pascal. It is a CGS unit for measurement of this pressure. So remember that what we have considered 3 points, again revised here, same points what we have studied in this lecture. First one, what is the meaning of fluid? There are two parts of this lesson, hydrostatic, hydrodynamics. Secondly, we have seen there the shearing stress for that one liquid or gases is equal to 0. It must consist of some of the properties that we have also studied here. That is, it is incompressible. Then you have studied there it is non-viscous. Then afterwards we have seen there it must have the steady flow, and these are the properties which we have already studied. When the shearing stress is not there, it is not having the effect of force can be observed very easily. So that we have to see that by using the pressure applied on that body. Force we can't measure it properly for the liquid, so that we are measuring pressure in any case of this liquid. Pressure can be calculated with the help of force only. Force and area. Area may be different inside the liquid. Not necessary everywhere the every particle is consist with the sphere or cylinder. Maybe it is a sphere. Maybe instead of this also you can consider a spherical part. The sphere is having a volume. We know that 4 by 3 pi r. And accordingly, area also you can find out, that is pi r square. So in this way, for a different bodies, it is applicable for that. But in this case, in your textbook, it is given for cylinder, so that you have to remember pressure exerted on any type of cylinder is equal to H R rho G. Okay? So that these points you have to remember. This is only the introduction of the lesson, mechanical properties of matter. Very important lesson for CET examination as well as board examination. And very easily you can write the answer of this question. Or this part I am giving you in the form of notes. You can copy down that notes, and then you have to see the concept related to that. In your textbook it is given very properly, so that read the textbook and write the notes. I will give the notes properly. So better way you can write first notes. If you have written the notes, then it is very easy for you to understand which derivation we have derived here in the college. So that I will give you the notes. I am going to post it on your WhatsApp group. Write the notes. Write the notes first. Even if I have not explained here, you write down that in your notebook. And that will be very helpful for you to understand the concept. And once you understood that, there is no problem. Okay? Thank you.